Action.
All right. First of all, number 23, this is section 4.4, the homework. We only have one critical value, and I'm just going to put, we did these in class the other day. We have one critical value, and the critical value is at -5. What you do is set the numerator and denominator equal to 0. There's only one variable here, so it's at -5. So when you do your critical, your exclusion chart, all of the critical values are up on top, and all your factors are on the bottom, with f of x being the bottom, the last row. So for this one, there are no roots because there are no variables in the numerator. And there is a vertical asymptote at -5, so x equals -5. You should have a vertical line at -5. And it's bottom heavy, so y equals 0 is your horizontal asymptote. If it's bottom heavy, it can't have a slant or a parabolic asymptote. To find the y-intercept, plug 0 in for x, and you get 0, 1/5. So 0, 1/5, you should have a dot. There is no hole, there's nothing that crossed out. So when you did your exclusion chart, you should have, to the left of -5, it should be in the negative region, so your graph should look like negative there, and positive to the right of -5. So don't forget to run through your y-intercept there. For 25, you should have, your critical values are only at -2.5. There are no roots because there's no variable in the numerator. Your vertical asymptote is x equals -2.5. And again, it's bottom heavy, so y equals 0, so it can't have a slant or a parabolic asymptote. To find the y-intercept, you plug 0 in for x, so you get 0, -3/5, no hole. Again, your exclusion chart looks like this, plus and minus at the end, and this is what your graph should look like. So we're starting on 27. Here's 27. So we have two variables, 3x on top and x on the bottom. So we have two critical values at x equals 0 and at x equals 1. So when you do your exclusion chart here, you should put a 0 and a 1 on top. And alongside here, you're going to have 3x and x minus 1. And then, of course, f of x. So find your 0 here. I would set this equal to 0, so you have your 0 here. To the left are going to be negative, and these are going to be positive. And find your 0 here, which is at 1. These are going to be negative. This is going to be positive. So count. You get a positive here, negative, and positive. So your roots. Your roots are where the numerator is set equal to 0, so you have x equals 0. I would right away put a dot at 0. That's your x-intercept. And since this is your x-intercept, this is also going to be your y-intercept. You can't cross the y-axis two spots. So if it's your x-intercept, it's also your y-intercept. Your vertical asymptote is going to be the line x equals 1. So we're going to put at x equals 1 a broken line. Now, is this bottom heavy, top heavy? What's the deal? The degrees are the same. When the degrees of the numerator and denominator are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator, which is 3 over 1. So y equals 3 is your horizontal asymptote, which is right here, y equals 3. So since there is a horizontal asymptote, there can't be a slant or a parabolic one. And there were no holes, we didn't cross anything out. So here we go, let's put everything in place here. It says, according to our exclusion chart, from -infinity to 0, -infinity to 0, we're in the negative region. So we're going to be in the positive region. So we're going to follow this asymptote, come down, pick this up. Then from 0 to 1, there's 0 to 1, we're going to be in the negative region, so which would be down here, follow this asymptote. And then from 1 to infinity, it says we're in the positive region. So we want to be, you're not going to want to position yourself in this positive region because then you're going to end up, your graph would end up crossing the x-axis. So this would contain us, these two asymptotes would contain us in that positive region. Anyone have any questions on this one? Okay, 29, next one. This one is an interesting one. This one, you've got to be careful when you find your critical values. First of all, what are the two critical values? Set this equal to 0 and this one equal to 0. X equals 3 is 1, but what's this one?
2.
What is it?
2.
It's 2. So when we do this, we have a 2 here and a 3. When we do our factors, we have 2 minus x, we have x minus 3, and f of x. This one you got to be careful with. When my little trick, my little shortcut, when I told you to find the 0, so normally you would go here, and then I said to the left is going to be negative, and this one's the opposite. This is the weird one that I told you there's going to be a weird one, that my little trick doesn't work. This one doesn't work. It's actually the reverse. This side's going to be positive, these are going to be negative. Think about it. If you picked a number to the left of 2, let's say 1, if I put 1 right here, what's 2 minus 1? It's 1. If I put 0, any number to the left of 2 is going to give us a positive number here. Now watch when I pick a number between 2 and 3, like 2.5. If I put 2.5 here, this is going to be negative. If I put a number like 4 here, what's 2 minus 4? It's negative. Does everyone understand why these are reversed now? Okay. Now this one works. My 0 is at 3 right here. These will be negative like normal, and they'll be positive. So count. You have a negative, positive, negative. So let's fly through these. What is our root? Our root is at 2, right here. At 2, put a dot. X equals 2. That's our root. Our vertical asymptote is x equals 3. So I want you to draw a broken line at 3. Is this top heavy, bottom heavy? What is it? It's the same. So what is the leading coefficient? If I fixed it, it would look like this, negative x plus 2 over x minus 3. So the leading coefficient is negative 1 over 1. So y equals negative 1 is your horizontal asymptote. So does everyone understand? The degrees of this one is the same, top and bottom. So you take the leading coefficient of the top over the leading coefficient. It's not 2 over 1. It's the leading coefficient. You got to find it. It's negative 1 over 1. How do you find the y-intercept? You replace x for 0 and you get negative 2/3. I need you to put a dot at 0, negative 2/3. And is there a hole? Did we cross anything out? Nope. So let's put this from negative infinity to 2. We're in the negative. So we're going to go like this. Pick up this. Then we're in the positive. And then we're in the negative. Questions?
What's the CV?
Critical values. Those are where the numerator, these are all these numbers right here. Critical values. Anybody have any questions on this one? $31. We have two critical values. What are they? 0 and negative 1. Now, when you put your factors in this problem, make sure you want to put an x here. This x plus 1, you have to list it twice. Why? Because there's two of them. And if you don't, if you just write x plus 1, your chart, your graph is going to be off. When you count your number of negatives, it's gonna be off because you're losing a whole line of, you might have all negatives here. Oh. So this one, you have a 0 here, so these will be negative, positive, and then here you've got, your negative is at -1, so these will be negative, these will be positive, and it repeats again here. So these will cancel out, but yet these will make these negative. Does that make sense? So we have 3 negatives here, it's negative, positive, negative. That's gonna be our bottom line.
Why did you put negative?
For the second one.
For the second x plus 1.
Oh, I'm sorry. Oh my gosh. So this is negative. Thank you. So these are both positive. Thank you, thank you. Wait, negative, positive. Did I do that right? Negative, negative, positive. Yes. 1, 2, 3, negative. 1, negative, positive. Okay, now, there are no roots on this problem because there's no variable in the numerator. There are 2 vertical asymptotes at x equals 0 and at x equals -1. So let's put that in, x equals 0. Here is 1 asymptote and at -1. This is bottom heavy, so y equals 0 is going to be your horizontal asymptote. Questions? So we have y equals 0, it's bottom heavy. You know, y equals, tell me what the, if you put a 0 in here, what's 0 times anything? Can you have a y-intercept? No, and you have no hole. Okay, this is an interesting one. From negative infinity to -1, you're in the negative region. So look at your graph right here. If you have to, where are you limited to? Right there, in that little corner here. So what you're going to do is draw this right here. From -1 to 0, which is a skinny little corridor right here, you're limited to the negative region. So what you're going to do is draw a little parabola. Because you don't want to cross that asymptote, and then you're in the positive region from 0 to infinity. Everyone got that? Questions? 33. What should we do with 33? I want to factor the denominator. X plus 2, x minus 1. Why do I need to do that? Well, I need to find the critical values, so I can do my exclusion chart, and I also need to find my asymptotes, my verticals. So, in my exclusion chart, my critical values are 3, -2, and 1. So we have 3, -2, and 1. The smallest of which is -2, then 1, and then 3. So make sure when you do these, you leave room after the 3 and before the 2. So we're going to construct so how many of these do we need? We need 3 factors. We have x minus 3, we have x plus 2, and we have x minus 1. And then the f of x is the grand finale. So x minus 3. 3 is our 0, so these will be negative to the left and positive. -2 is our 0, negatives and positives after, and 1, negatives and positives. Now we count. 3 means negative, 2 means positive, negative, positive. Next, where are my roots? 3. Right away, put a dot at 3. What are my vertical asymptotes? X equals -2 and x equals 1. So at -2, put a broken line, and at 1, broken line. How about the horizontal asymptotes? This is bottom heavy. I've got degree of 1 here and degree of 2, so y equals 0. So that means there can only be one of these 3. This means bottom heavy, or degrees are the same. And this is top heavy by 1, top heavy by 2. So this is saying that we have a horizontal asymptote like that, and that's what I'll just do. I'll just do a broken line here. Now remember, we do have a y-intercept at 3. So it's obviously crossing. It can cross a horizontal asymptote. Horizontal asymptotes are more for the end behavior. It's a weaker asymptote. Is there a hole? No. And what's the y-intercept? I would go back, when you do the y-intercept, go back to the original. Cross out, cross out, cross out. So you get 0, comma, -3 over -2 is 1.5. So 0, 1.5. Right there. Now let's start putting our stuff on the graph. So from -infinity to -2, it says we're in the negative region. I'm just going to draw that. So then we're in the positive region. From -2 to 1, we're in the positive region. Looks like it's going to do something like this. Then from 3 to infinity, actually this is going to go up, because it's not going to cross, it's going to go like that. It's going to go like that, positive. And from 3 to infinity, it's in the positive. So, do I have this right? Where's the negative? From -infinity to -2, it's in the negative. We got that. Then we're positive. -2 to 1, we're in the positive. And then from 1 to 3, we're in the negative. And then we're positive. There we go. So from 1 to 3, we're in the positive, or negative, I'm sorry. 1 to 3, we're in the negative, and then from 3 to infinity, we're in the positive. So what's happening is, if you had to see these y equals 0 asymptotes, so what ends up happening is this is going to go, it's going to cross over here, and then it follows itself along the x-axis. Okay, questions on that one? Now, if you wanted exact points, now this is probably, it's probably more like a parabola. If you wanted more exact points, that's when you have to pull a t-chart into play and plug points in. Oh, this one looks fun, 35. So, a lot of people think of this one, oh, we have a hole. We do not have a hole in this one. Why not? You're going to factor this x squared plus 6x plus 5. You always want to reduce your problem. We've got 2x plus 5s on top, but we have 3 of them on the bottom. We have 3. We have too many on the bottom. So in the numerator, we are stuck with x plus 1, or left with x plus 1. And in the bottom, we have x plus 5 times x minus 1. Now, if we would have canceled this x plus 5, let's say this was x plus 5 squared, and we lost these two and the 2 here, then we would have a hole at negative 5. But we don't have a hole. So there is no hole. It was close, no hole. So again, if I would have lost this, you would have had a hole at negative 5. You would have plugged negative 5 into what's remaining, and that would have been a hole. You put an open circle at that order pair. So now we are actually doing this problem, not that one. For a minute, it looked like we were doing that, but we're only doing this. So what are our critical values? Negative 5, negative 1, and 1. We have x plus 1, x plus 5, x minus 1, and f of x. So at negative 1, put a dot, negatives, positive, positive. At negative 5, negative to the left and positive to the right. At 1, these are negatives, and then positive. So we count. An odd number of negatives means negative. Even, positive, negative, positive. Any questions on this exclusion chart? What are our roots? Negative 1. So we're going to just draw our graph here. Wow, that was crooked. Negative 1, put a dot. We have vertical asymptotes at negative 5. Negative 5. And at 1. This is bottom heavy, y equals 0. Y-intercept at 0. If you put a 0 here, a 0 here, and a 0 here, 0 plus 1 is 1, 0 plus 5 is 5, and 0 minus 1 is negative 1, so it's negative 1/5. Right? Anyone get something different? Okay, so now we're going to put everything in place. So from negative infinity to negative 5, we're in the negative region. So something over here. From negative 5 to negative 1, it says we're in the positive region. Come down here, pick this up, then it's negative, and we're going to asymptote that down, and then positive. Anybody have any questions? Anyone? 37.
Can you go back to
Yes. Good? Okay. 37. What should we do? Can you set that equal to 0? And solve this one. If we subtracted 1 and divided by negative 4, do you get x squared equals 1/4? And then square root both sides. What do you get? Plus or minus 1. Square root of 1 is 1, square root of 4 is 2. So what are your critical values? There's 3 of them. Very good. Negative 1/2 would be your smallest, then 0, don't forget you have a 0 here, and then 1/2. Now, if you wanted to, you could do 2, when you do this right here, you could plug, it would just take you a longer time. You could put each one of these, like this whole set, you could write -4 x squared plus 1. So watch this show you. -4 x squared plus 1. You can make these x's separate if you want. There's a few things you can do. I'll show you. Or what you could do is you could rewrite this and factor it. You could write 1 minus 2x and 1 plus 2x and then factor it that way. So think about this. If you picked a number give me a number to the left of -1/2. Like, obviously, I would say -1. If you put -1 here, or what you could do, yeah, I would do that. I would pick a number to the left of -1/2. So think of a number line. You're 0. You're right here at -1/2. So -1. If you put -1 here and squared it, you get +1. Add negative, and multiply that by -4. That's going to be a negative, and then add 1 to it. That's a negative. Okay. If you picked a number between here and here, like -1/4, if you squared it, multiplied it by -4, and added 1, what would you get? Negative or positive? Negative? And then what's this going to be? So point. So if you put, let's say, put point, you can do this on a calculator too. Let me show you if I'm confusing anybody. So if you tested .25, which is -1/4, you're going to square it. So -0.25 squared times that by -4, and then add 1. Oh, that was positive. You goofed. Did everybody catch that? When you plugged -1/4 in here, and the reason is because that was your 0. So it should have changed over. Let's make sure we were right. So if you use -1/4, so -0.25, you're going to square it, multiply it by -4, and add 1. Yep, it's positive. My guess is these are all positive, so let's use 1/4. So 0.25 squared times that by -4 and add 1. That's also positive. And this is going to be positive. These are all positive. And these, whatever number, if it's negative, it's going to be negative. So any number here is negative. Any number here is negative. Positive, positive. So that you have an odd number of negatives, even, positive, positive. It's an interesting one. Okay, so now, let me erase this for room. Where are my roots? If we figured them out to be -1/2 and +1/2. Our vertical asymptote is x equals 0, which is your y-axis. This one's degrees are the same. You have a 2 here and a 2 here. So you have a horizontal asymptote at y equals -4. Do you know why? Because if the degrees are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator. So y equals -4. 1, 2, 3, 4. At your y, your horizontal asymptote. So that means there's no slant or parabolic. There's no hole. In your y-intercept, you can't have one because if you plugged 0 in here, it's undefined. So, how are we going to graph this? So remember, we have an asymptote here. We have an asymptote here. So, anyone have an idea how we're going to draw this? It says from -infinity to -1/2, we're in the negative region. So what I would do is draw from -infinity to -1/2. I would draw something up here, and then from -1/2 to 0, you're going to shoot up here. So it looks like this. Hmm?
Would 1/2 be, it's like 1/2 negative?
Would 1/2 be negative?
Yeah, like for the first one, the -4 is 2 + 1. So, like, let's say if you did like 2, so you do 2 squared, 4.
Show me where you're at. Right here?
Yes.
Okay. Right here?
Nope, the positive 1/2.
Positive 1/2. Over here,
Yeah.
it should be negative.
Well, wouldn't it make sense, because say if you did like 2, and you plugged in 2, squared would be 4, times -4 is
Yes.
-16, plus 1.
Yes. What did we do wrong? So if you plugged in, it should be negative. It should be negative. So we have an error here. If you plugged in, is this right? If you plugged in -1, -1 squared is a positive, negative, that's right. And then these two should be right, and that should be negative. So then this should be negative. So then, our graph goes from negative to positive, and then this should go like this. Yep, you are right, Tara. Yep. And it makes sense. That was our error. I was wondering why this wasn't working out. It's like a Christmas tree. Okay, 39. We need to factor the numerator. I would take an x out of the top, and you have x plus 2. The bottom you're going to factor to be x minus 5 and x plus 1. Let's check this out. -5 times 1 is -5. These two add to be -4. Are we going to cross anything out? No. So there's no hole. No hole. Nothing got crossed out completely. What are our roots and our critical values? Let's do the critical values first. Ooh, there's a lot of them. We have 0, -2. So -2 is our smallest, right? -2 is our smallest. Then we have -1. Then we have 0. And we have 5. So on the side here, I've got x. I have x plus 2. I have x minus 5. And x plus 1. And then f of x at the very bottom. Now this will be an easy exclusion chart. At 0, These will be negatives, and this will be positive. At x plus 2, we have a negative here, and these will be positives. 5 here, these are negatives, positive. -1, we've got negatives here, positives here, and then count 1, 2, 3, 4. Positive, negative, positive, 1 negative, negative, and positive. Where are the roots? We have 2 roots at 0 and -2. So here's my graph. At 0 and at -2. Those are your roots. Our vertical asymptotes, x equals 5 and x equals -1. 1, 2, 3, 4, 5, vertical line, and at -1. This one, the degrees are exactly the same. So y equals what? Anybody? 1. And if you put a 0 here and a 0 here, you get 0 over 0. Which you already had a root at 0, so that's your, so let's put y equals 1. So how do you graph this one? From -infinity to -2, it says we're in the positive region. So where would I graph if I'm from here, I'm going to be positive? Do I want to go in this region? No, I'm going to want to stick in this positive region and come here. And from -2 to -1, I'm in the negative region. So I'm going to follow this down. Then I'm in the positive region. So from -1 to 0, I'm in the positive region. Which I'm stuck. One, 2, we're in the positive. We are stuck here. And then it says negative. This is positive right here. Zero, 0. We have some.
You go through the horizontal asymptotes.
I don't think this one's going to go through like that. I don't think, but let's check it out. And then negative. We have to come down here. Let's graph this one and see.
It's a parabola.
Huh? It's a parabola?
That's what Brett said.
Did you graph it?
Did you graph it, Brett?
Went from -1 to 0, would there be a parabola like above the horizontal asymptote?
How did it pick that up? Did you graph it?
No.
Oh. I thought you did. Okay. Let's do x in the numerator. We have x squared plus 2x, and then divided by, and then in the denominator we have x squared minus 4x minus 5. It did cross it. So it did cross it. There it is. We were right. Our graph was right. We did cross that asymptote. I didn't want to, but I guess we had to. We didn't have a choice. It was the only way. Okay, did everybody see that? How it worked? See, there is an asymptote. It's right there. And we had to cross there. So unfortunately, this is a weird case. You won't have very many of those. And notice how which question we're on 39. We're near the end. they're more challenging here. So, yeah, remember, horizontal asymptotes are weaker, and they're more for the end. Horizontal are for end, think of end behavior. Okay? Now, I want to at least get to 41. Why is 41 important? Because there's a hole here. This one has a hole. If I can just cover the hole, I'll be happy. Where is the hole? You cross these out. The hole is at -3, comma. You're going to plug -3 in here. Your problem that you are actually going to do is x minus 3 over x minus 5, x plus 4. So if you completely cross out a factor and lose it completely, you have a hole at -3, comma what? You're going to plug -3 here, here, and here. So what's -3 minus 3 over -3 minus 5, which is -8, times -3 plus 4, which is 1. So it's -6 over -8, which is 3/4. So you have a hole at 3/4. -3, 3/4. So when you graph this one, on your graph, you're going to put an open circle, a break at -3, 3/4. Okay? So, I'll show you really quick because we're running out of time. Here's what it looks like. You have, your roots are at 3, right here. Your vertical asymptote is 5 and -4. It's bottom heavy, so y equals 0 is your horizontal asymptote. And again, I have 3/20ths. I said -3 is your -3 plus 4 is 1. So that's right. 1. Right? You plug -3 in here. So -3 minus 5 is -8, and -3 plus 4. Oh, I was looking at, I was looking at the y-intercept. That's why. That's why. Okay, so that's right. 3/4. So 3/4. And then your y-intercept is 0, comma 3/20. To get your y-intercept, you're going to plug 0 in here, here, and here. You get 3/20. So here is the exclusion chart. And this is what the graph looks like. This is your hole. When you graph this at -3, 3/4, you're going to have an open circle on your graph. Now obviously mine's not drawn perfectly, but that's what you should have, basically. Questions? Okay, the last 3 will be, if you want to look on YouTube.